Hello. Today's our lesson on 3.4, which is special right triangles. So let's start with our warm-up. And we have 4 problems, but 3 of them are very different than number 1. 2, 3, and 4 all have information about angles, and we're looking for an angle. Same with these, although I didn't put the x values. So let's do that. Sorry about that. So problem number 1, though, is exterior side lengths, and we're looking for one of those sides. If they're right triangles and we're looking for a side, we could use Pythagorean theorem. Pythagorean theorem says the leg squared plus the leg squared is equal to the hypotenuse squared. A squared plus b squared equals c squared. And we'll solve these. 36 plus x squared equals 121, and subtract the 36, adjusting things, subtract 36, and we get x squared is equal to 85. And to undo a power, we want x all by itself, we'll square root, and we get x is the square root of 85 is how Apex will leave it. I mean, even if we could simplify that square root, Apex will leave it just as the square root. Okay, so Pythagorean theorem, that's used in right triangles only if you're looking for an outer side and you're given 2 sides. If it's about the angles inside, and we have 2 of the angles and we're looking for the other, we could use triangle sum theorem. We could say 45 plus 90 plus x is 180. We could do that. But we don't need to, right? We could. We don't need to, though, because we learned about a week ago for isosceles triangles, the angles opposite, if it's an isosceles, the angles opposite those equal sides are also equal angles. So we could do that work, but we could also remember a rule we learned, and that just tells us the answer. X must be 45 degrees. If you need to, use triangle sum, but it's helpful to know rules, kind of shortcuts. This turns out to be a special right triangle. So it's called special, I'll abbreviate right triangle. There are 2 types of special right triangles. This one is called a 45, 45, 90 special right triangle. And it's special because there's a relationship between the sides and the hypotenuse. There's a ratio, and we're going to learn that today. It's a really important lesson. That's partly why I'm recording it. Anyway, stay with me. Don't leave your device. Pause if you need to. Take a break at some point because it's recorded, right? All right, let's try number 3. We could use triangle sum theorem because we have a 90-degree angle and a 30-degree angle. We need to find the third angle, and they add up to 180 by triangle sum theorem. We get 120 plus x equals 180. Subtract that 120, and x is 60 degrees. That is the other type of special right triangle. Special right, I'm squeezing that in. Special right triangle. This one's a 30, 60, 90 triangle. They both have 90-degree angles. That's why they're right triangles. They're special when they have 2 45 degrees or a 30 and a 60 with the 90. 30, 60, 90-degree triangles also have a special relationship or ratio with the sides and the hypotenuse that we're going to go over in a bit. For number 4, they gave us the 60-degree and the 90. We could do triangle sum again, but look here. We have a 60 and a 90. The other one's 30, right? If one's 60, the other's 90, the third one has to be 30 degrees. We kind of discovered both in number 3. So x must be 30 degrees. You could do triangle sum theorem if you want, but it's not necessary. Okay, that's our warm-up. Quick last minute screenshot of it if you missed some part. Of course, you could just rewind. I'm just used to that method. All right, we have got notes that I'm going to go over fairly quickly. It's recorded again, you can pause, but you're going to need to write these on your own. So I strongly recommend, this is probably the most difficult topic of the year, but at the same time, it's the most important topic of the year. So the notes I have on special right triangles go over 30, 60, 90s. And again, we have a relationship or a ratio between the short leg, the long leg, and the hypotenuse. The short leg is always between 60 and 90 degrees, always. Even if it doesn't look like that, sometimes we'll try to trick you by making the triangle look like it's not the short leg. Just check the numbers. It's between 60 and 90, that's the short leg. The long leg's always between 30 and 90. Its relationship with the short leg is that it is the square root of 3 times longer than the short leg. If I choose to name the short leg N, then the long leg is N, the short leg, times the square root of 3. That's their relationship. That's their ratio. The hypotenuse also has a relationship with the short leg. It is twice as long as the short leg. So if I name the short leg N, then the hypotenuse has to be 2N, 2 times N. Let's put some numbers in place. What if the short leg was 6? That would make the hypotenuse 2 times 6, which is 12. That would make the long leg 6 times the square root of 3. And we're not going to calculate that. It's not particularly useful to give me the estimate. It's much more important to give me 6 times the square root of 3. We don't calculate the square root of 3 when we work with special right triangles. And then the same is true, not the same, we also have a relationship with 45, 45, 90 triangles. And that is, if it's 45, 45, 90, the two legs must be equal. If these are equal angles, these are equal legs, meaning it's an isosceles right triangle. The legs are the same. So if I call one N, the other one also has to be N. So their relationship is that they are equal. But the relationship with the hypotenuse and the legs is that the hypotenuse is the square root of 2 times longer than the leg. So again, if the legs were 6, this would be 6, this would be 6, the hypotenuse would be 6 times the square root of 2. And that's how we would leave it, just that, 6 times the square root of 2. Okay. Now, why is this all useful? When we're trying to solve for missing parts in a special right triangle, we follow these 3 steps. I need to add a little bit, but I'll say it, you're going to write it. Probably should rewrite these. If I'm trying to solve for a side or a hypotenuse of a special right triangle, step 1, we're going to label the side relationships or ratios. We're going to put equal signs with that given information, whatever they might give us. We'll put an equal sign with the ratio. This is going to make a lot of sense when we start doing the problems, by the way. It always is like, we talk about it, it seems a little bit confusing, and then we start playing with it, doing it, practicing it. It gets better every practice problem. And the first few will be confusing, and then the 3rd and 4th will be easier, and the 10th and 12th will be easier, and so on. Step 2, we solve for n. I should have written for n. Solve for n in the equation that we created with the given information. You're going to see what I mean by that as we do the problems. My dog is barking in the background. Step 3, we plug in the value for n that we got in step 2 on each of the other sides, and then simplify if we can or if we need to. It might just be the answer right there, or we might have to do a little calculating or simplifying. All right, so that probably doesn't mean a lot to you. These are the important steps here. Let's look at some more notes. I posted for you some examples of 30, 60, 90. Here's a sample problem of a 30, 60, 90. I did a simple one. That means it doesn't get too complicated. Step 1, step 2, step 3, you're going to look at these on your own. And then I did a complex problem where things get more tricky and difficult. But the steps are the same. If you follow those steps exactly the way I word it, you will get the right answer every time. It doesn't matter how difficult or complex the problem is. The steps are the same. So I have a 30, 60, 90, and then I also have a 45, 45, 90 where I did a simple problem and then I did a more complex problem. I recommend you keep your notes out in front of you while you're doing these problems, especially the first page of notes. And then if you get stuck, you might look at those sample problems that I posted. Okay, we're going to do the 3.4 checkup. 3.4. I'm going to do all of it. It's just such an important concept, and having just 10 problems isn't enough. So this one, I'm going to do all of it. And we're going to practice again the next time we meet on this same topic. So we'll spend 2 days on 3.4. Number 1, we have a special right triangle. They give us this information. They say it's 60 degrees here. I hate that they use the variable s, and they want us to find s. All right, we got this. Let me get my pen set up. Step 1. So you would be looking at your notes. I have them memorized. You're looking at your notes. You're like, I'm going to do the problem. What do I need? You go to your notes. Step 1 says, label the ratio of the sides. Okay, this is the short leg. I know that it's the short leg, not because it looks like it's the short leg, but because it's between 60 and 90. And the short leg is my n value. Notice I put an equals with it. Just for practice, just to get it all memorized, the hypotenuse is 2 times n. In this problem, it doesn't matter, but let's just write it anyway for good practice. The long leg is between 90 and 30 degrees. That has to be 30 by triangle sum theorem. I don't even need to write it, but it must be, right? And the long leg is n times the square root of 3. It's a little sloppy, hard to read. N times the square root of 3. How do I know? You're looking at your notes. I have it memorized. You're going to have it memorized within a day or two. We're going to do enough problems to get it committed to memory. It's very important. Step 1 done. Label the ratio of the sides. Notice with each one, I put an equal sign with the given information. I put an equal sign with the variable they gave me. Step 2, solve the equation that we created with the given information. I can't solve this one because I have 2 variables. I have to know what one of the variables is in order to solve it. But I can solve this one. Matter of fact, I don't even have to. It's already solved. Sweet. Check, done. Step 2 is done. I solved for n. I didn't even have to solve it. It was there. N is 12. Good stuff. When I know the n value, I know everything. I can plug in the n value. I could even plug it in here, but they're not asking me to. But I can plug in the n value to solve for all of the other sides. If they ask me for the hypotenuse, it'd be easy, right? It's n times 2. It's 12 times 2 is 24. They're not asking me for that, but we're just showing off. Let's solve for everything. It's good practice. We have to solve for s. So I don't have a lot of space. I'm going to write it over here. I have s on the right side, and I have it is equal to the square root of 3, and that's being multiplied by n. What's n? 12. There's my s value. It is 12 times the square root of 3. We're not going to put that in our calculator. We're going to leave it just like that. That is a better answer. When we kind of get to the next steps, we work with it with other areas in Math 3. So we prefer to leave it that way, not the decimal calculator answer. And by the way, with these complicated problems, we're never going to touch a calculator. It doesn't matter how complicated they get, as long as we know the ratio of the sides and all of the steps. Let's try number 2. Separate it off. Number 2 looks like this. I don't know why I'm pausing. It's just habit. You guys can pause. I'm not going to go that slow. I'm going to pick up my pace. Because again, if I go too fast, just pause, right? That is a terrible looking 30, 60, 90, but it's 30, 60, 90. I'm glad I wrote it that way. It doesn't look like a 30, 60, 90, but it doesn't matter what it looks like. The numbers are proof. If that's 30 and that's 90, that's got to be 60. Therefore, it's a 30, 60, 90 triangle, even though it doesn't really look like it. It is a little hard to tell what the short leg is because of the way I drew it, but I know the short leg is between 60 and 90, so this must be the short leg. And when I label the ratio of the sides, the short leg is n. The long leg is n times the square root of 3. I don't really need that one on this problem because they're not asking me to solve the long leg. The hypotenuse is 2 times n. Step 1, label the ratio of the sides. Step 2, solve for n. I can't solve for n here because I have 2 variables. I can here, in fact, I don't have to. It's already done for me. Step 2, the n value is 4. Again, so far they're real easy. They're going to step it up in a little bit. We take that n value and we plug it in. We could also plug it in here even if they're not asking us to. We'll just do this one. Step 3, plug in the n value. The n value is 4. Therefore, the hypotenuse is 8. Again, that's such a simple problem. You probably, if you're getting this quickly, you could have said, Ms. Brown, it's 8. Do I have to do all that? Well, sure, it's a simple problem. Wait till it gets more difficult. It's very important to follow these 3 steps, even when it's a simple problem. All right. Fast forward a bit if you want. It takes me a second to clear my board. Not too long. Then I got to write number 3. Go ahead and fast forward while I write up number 3. Number 3. I'll try to make it look a little bit more, that's way too long leg-ish. And then we have 30 degrees here. That's the long leg between 90 and 30. The hypotenuse is given. It's cut off, but they want us to find x and s. Okay, we got this. Step 1, label the ratio of the sides. This is a 30, 60, 90 triangle. This is 60. Therefore, this is the short leg. That's n. Notice I put an equal sign with it. The hypotenuse is 2 times n. The long leg is n times the square root of 3. Step 2. How do I know that, by the way? I have it memorized. How do you know it? You're checking your notes. You're going to need your notes until you've done this for a week or so. Have them in front of you. Please rewrite those notes. Don't just look at mine. Put them in your own handwriting. Solve the equation created with the given information. I can't solve that one because it's 2 variables. I can't solve that one because it has 2 variables. This is the only one I can solve, so that's the one I'm gonna solve. Here we go. 10 equals 2 times n. It's still pretty simple, but I actually have to do some solving here. We'll divide out 2, creating a 1. 1 times n is n. 2 goes into 10 5 times. Step 2, done. N is 5. The goal is to figure out what n is. N is like the mystery number. Once you have n, you have everything. You can take n and plug it in to all of the other areas and find the information. So let's plug in n. N is 5. That equals x, so x is 5. The next one, s equals n, which is 5, times the square root of 3. S equals n, which is 5, times the square root of 3. That's what I wrote. If I needed to simplify those, I would, but I don't. We don't calculate the square root of 3. We just leave it 5 square root 3. Good stuff. Number 3 is done. I'm pausing for questions, which is so silly because you're not even there. Let's do number 4. Number 4 is a word problem. So you should be looking at your checkup paper. It says a street sign company is making street signs in the shape of equilateral triangles. Let's stop right there. Let's draw an equilateral-ish triangle. That kind of looks like an equilateral triangle. Equilateral triangles not only have equal sides, they have equal angles, and we talked about this a week or so ago. Those angles are all, 60 degrees. Those look like terrible 60s, but okay. It says the side length of each sine is 22 inches. So I do a little read, and then every time I get information, we want to write it down. They're all 22 inches on the sides. It says, what is the exact altitude? The altitude is the straight up and down. Let's see if I can get this nice. Oh, it's a little off. And altitude is perpendicular to the base of the triangle. Well, since I drew that in, I split this angle in half. This 60-degree angle has now been cut in half. And half of 60 is 30. Gosh, that looks bad. Okay, better. Half of 60 is 30. It's still pretty bad. Do you see where I'm going with this? We've got a 30, 60, 90 triangle. That's something we can work with. It says, what's the exact altitude? So we're looking for this height. I'm going to call it A for altitude. And I don't need this side of the triangle. I just need that 30, 60, 90. More information is always better. If this whole thing is 22, then this portion of it must be 11. We cut it in half when we drew in that altitude. And again, I don't need this whole thing. Let's just ignore that. This is the stuff I really need. That's my focus. I've got a 30, 60, 90 triangle. I'm going to follow my steps in solving for A. Step 1, label the ratio of the sides. The short leg is n. The hypotenuse is 2n. The long leg is m square root 3. How do I know? Because I have it memorized. You have your notes, you're going to memorize it. Step 2, solve for n. If I didn't have this information, I could divide by 2 here, and I would get this information, but we have it. Step 2 is done. Step 3, your notes tell us to plug in that n information, and we'll have the altitude. A equals n, which is 11, times the square root of 3. That's the altitude, the height of the triangle. Number 4. Again, I don't know why I'm pausing. It's kind of comical, actually. I'm going to erase my board and set up 5. You want to fast forward while I do this probably until I get it all set up. It is funny that I'm pausing. Okay. Number 5. I'm going to try to make this bigger. We have this cut. Why can't I draw it straight? That's terrible. Erase. Hopefully you're fast forwarding all this until I get it right. Better. I can do better. Oh, no. Oh, it's worse. It's a little better. All right, 30 here. A is here. 10 root 3. 10 root 3. 5 root 3. 5 root 3. These are right angles, and this is 60. All right. Now we're ready to start. I drew it all sideways. So funny. It says, what's the length of A? We're looking for A. Again, I don't need all of this. Thank you for it, but no thank you. I just need that 30, 60, 90 triangle, right? You can ignore the other part. Step 1, label the ratio of the sides. N, hypotenuse is 2n. The altitude, or the long leg, is n square root 3. Step 2, solve for n. I could solve this for n by dividing out 2, but this one's already solved for n. You keep giving me nice, neat, pretty ones. Step 2 is done. The n value is 5 times the square root of 3. Now let's stop here and say, hold on. If this is bothering you a little, and maybe it should, students will say, Miss Brown, I don't understand why the square root of 3 is at the short leg, because the square root of 3 should be at the long leg. Please listen. 5 times the square root of 3 is a measurement of distance. from the 90 degree to the 60 degree angle. This side length is a distance of 5 times the square root of 3. This square root of 3 is not a distance. It's a relationship with the short leg. It is the square root of 3 times longer than the short leg. This one's a relationship. This one is a distance. They have two different kind of meanings in this problem. So don't be bothered if the square root of 3 is here in the hypotenuse or the short leg. When you're like, no, it belongs in the long leg, that's true with the ratio. But the measurement of distance could have a square root of 7 or 3 or 2 or anything. It's whatever the distance happens to be. Now that we know n, we take that information and plug it in and solve this equation. So we have a is equal to n times the square root of 3. N is 5 times the square root of 3. Why am I all sideways here? 5 times the square root of 3. This was the n value. I have arrows going everywhere. The n value happens to have a square root of 3 in it, but the long leg has a relationship with the short leg. That is the square root of 3 times longer than the short leg. What we have here is three things. We have 5 being multiplied by the square root of 3, which is also being multiplied by the square root of 3. I don't know why I'm all crooked. I'm just multiplying 3 things right here. When I multiply those two, and the order that I multiply doesn't matter, I'm going to multiply the 2 square roots together first. And the square root of 3 times the square root of 3 is 3. I want that to look a little better. I just brought the 5 straight down. It's being multiplied by the solution to the square root of 3 to the square root of 3. Here's what I mean. The square root of 3 times the square root of 3 is really the square root of 9, which is 3. That's how I got that 3. And now I'm almost there. A is 5 times 3. They wanted me to solve for A. We finally made it. Okay, let's do number 6. Let me erase, fast forward till you see my problem written. It's so strange to keep going. I'm trying not to pause, but I kind of can't help myself. Number 6. Finally, we've got a 45, 45, 90 triangle. We haven't done any of those yet. The problem, or the steps, I should say, are the same. All right, that's what we have. And we need to do step 1, label the ratio of the sides. For 45, oops, I know what's not here is this information, and it is important. That tells us it's a 45, 45, 90. So in a 45, 45, 90, the legs are both n. The ratio is different than a 30, 60, 90. The legs are both n. The hypotenuse is 2 times, no it isn't, sorry. I'm thinking 30, 60, 90. Hello. The hypotenuse is n times the square root of 2. These are the ratios for a 45, 45, 90. I really don't need this information. This is totally useless. If all I'm finding is S, and S is the leg, and the legs are equal, okay, well, let's go do the steps anyway. Step 1, label the ratio. Step 2, solve for n. Again, they did it. It's already solved. Step 3, plug in the n value. And we have our answer. S is n. I hate the variable s because it looks just like a 5, and the answer is 5, and they look, yeah, whatever. S is 5. The 2 legs are the same in a 45, 45, 90. You're like, Ms. Brown, I didn't need to do all that. No, of course you didn't. But it's good practice because when the problems get complicated, you do need to do it. Here we go. Number 7. Again, I'm pausing. Stop pausing. Number 7. Another 45, 40. I can't draw triangles today. Oh boy. We have 12 and 12 and 45 here, and we're looking for S. Step 1, label the ratio of the sides. The legs are both n. The hypotenuse is n times the square root of 2. I have it memorized. You will have it memorized after you've done a whole bunch of problems. Solve for n, already done. We have it done twice. We don't need it twice. We just need it once. No calculation required for step 2. Step 3, plug in the n value. So I'm going to rewrite this over here. S equals n times the square root of 2. Once again, we don't calculate that. We just leave it as is. I'm going to erase. Sorry. Fast forward. There we go. Until you see the problem drawn, keep fast forwarding. Number 8. Square root 2, 45 here, and s. Step 1, label the ratio of the sides. Glasses are killing me. Label the ratio of the sides. The legs are both n. I don't need to label that one, but whatever. Good practice, good habits. The hypotenuse is n times the square root of 2. Step 2, solve the equation created with the given information and the ratio. We can't solve that, not yet. We can solve this. We want to get n by itself. We got to get rid of that square root of 2. We'll divide it out, creating a 1. Here it creates a 1. I'll write n over here. Here it creates a 1 and is 8. Step 3, take that n value and plug it in. S is 8. And again, I realize many of you could have just seen that and had your answer. It's good practice to follow those steps, because when the problems get complicated, you're going to be happy you know those steps. Here we go, number 9. Number 9 looks like a square. Doesn't matter what it looks like, I'm just saying, but we could prove that that's a square. Anyway, we've got 14 here, S over here, that's 90 degrees. This is also 90 degrees. Kind of wishing they had drawn that in, but anyway. Gosh, I'm all crooked. Okay, I don't need this guy. That's not useful. It's almost like they're trying to confuse us. We cannot be fooled. Step 1, label the ratio of the sides. The legs are both n. The hypotenuse is n times the square root of 2. We are about to step it up a notch. Things are about to get difficult. Step 2, solve the equation created here. I'm going to rewrite it over here. N square root of 2 equals 14. To solve that, we're going to divide out the square root of 2 on both sides, creating a 1 here, leaving us with n by itself. Sorry, I would rather write this in black. I want it to show up really good. So we cancel there, creates a 1. We have 14 over the square root of 2. That looks good, but it's not. In the math world, we can't leave a denominator with a square root in it. We're not allowed. It's against the rules. They don't like it. We've got to fix it. It's called rationalize the denominator. Get rid of the radical. Here's how we do it. We're going to multiply by 1. The 1 that I'm choosing to multiply by is the square root of 2 over the square root of 2. If I multiply by 1, I'm not changing its value. I can pick any 1 I want, but the point is to try to rationalize the denominator, and I want to get rid of the radical. If I multiply the square root of 2 times the square root of 2, I get a denominator that's just plain 2 when I multiply straight across. Same up here, not same, sorry. Up top, if I multiply straight across, I get 14 times the square root of 2. So now my n value, it looks a lot more complicated, but it's a better look for the math world. We don't like denominators that have radicals. It's no good. Can't leave it like that. We also can't leave it like that. These two can reduce. This 2 cannot reduce with the denominator 2 because that's not a 2. That is the square root of 2, which is 1 point. Who cares? But whatever it is, it's not divisible by 2. So you cannot reduce the square root of 2 with 2, but you can reduce 14 in 2. So that's going to give us an n value of 7 times the square root of 2. Finally, all that work, and we have an n value. So we really stepped things up a notch with this problem. We had a lot going on, a lot to deal with. But step 2 is done. Take that information, plug it in. Take the n value and plug it in. So s is equal to n. N is 7 times the square root of 2. And finally, we're done. So number 9 really stepped it up. And guess what? I'm going to let you do number 10. Number 10 is so much like 9. Look at the steps for number 9, and you will be able to do number 10. I'm leaving you one of the harder ones, but we did all this practice so that we're able to do the harder ones. Just try it. All right, we made it. Rewrite those notes. You got this. Have a great day.